Hello, my name is David Gioretta, Director for the Alliance for Permanent Access. I'd like to present to you a preview of the course that we're offering on an overview, an introduction to digital preservation. So I'll begin by talking about digital objects and preservation and OEIS. So first, what's special about digital objects? Well, in a sense, it's because you can't see the bits. You tend to need special hardware or software which may become unavailable. Although, of course, there are some special cases. Here is a CD-ROM. You can see the pits in the media, although they're not quite bits because of the error encoding and bit stuffing. There are encodings on microfiche which have dots for the bits, and those can be seen with the naked eye and the magnifying glass, but they tend to need processing. It's hard to see if things have been changed. Copies tend to need to be made as the underlying material decays, and are those copies true? Is there, to use the term, digital decay? So that's one thing, but digital objects are more complicated than people do tend to think about, because we all tend to live in dealing with familiar objects. So let's just think many of those are simple documents: Word, PDF, images, so GIF, JPEG, and really they're meant to be just displayed for human viewing. But there's another type of digital object. I'll refer to it simply as scientific data. It's encoded in bits, it contains numbers and text, and it's not usually for viewing those numbers by a human. I mean, one can if one wishes, but it's not terribly useful, because you can't just guess at what those numbers mean. Even in the best organized formats, things are never really self-documenting. There are also other sorts of digital objects, even more complex. They can be scientific data as well, but for example, databases where the interrelationships between the elements affect the meaning. And there is a type of digital object that changes over time, strange in terms of digital preservation, but we may need to preserve the state at various points of time, and that introduces another set of challenges, for example with annotations. So let's think about what digital digital preservation might mean. Is it keeping the bits unchanged? Well, yes, but over time we might need to change the format, change how it's encoded in order to make things useful. Is it adequate just to be able to print, view whatever it is at some later time, that it's sufficiently similar to the original? Yes, but for scientific data, as I've indicated, that's not really adequate. Is it enough just to be able, even for scientific data, to be able to redo what's been done previously, for example, emulating software? Yes, but again, that's not usually adequate for digital preservation for data, especially when it comes to getting benefits out of the data. So I've been leading into a number of the concepts that will be covered in much greater detail in the course. There are many options that are out there in terms of preservation. Keeping lots of copies, well, it's kind of keeping the bits. Software vendors, I think experience suggests no. Magic preservation format, many espouse XML. Where was XML 30 years ago? Where would it be in 30 years' time? And even with very simple XML, where you can guess most of the tags, it's possible to encode anything, including software, into XML in a very proper encoded form, and many of the current document encodings can do that. Special media, well, the media, for example, you can carve the ones and zeros in stone if you really wanted to, last for thousands of years. But for most of the media, the hardware and software needed to extract the information tends to not be into production, not be available after quite a small number of years. And there are other options which we'll cover in more detail and look at the pros and the cons. We base what we do on the OAIS reference model because it brings together, in a fairly abstract way, but a coherent set of concepts and terminology which is it's an ISO standard but extremely broadly adopted. So it defines preservation in this way: independently understandable by a designated community with evidence supporting authenticity. And these terms are themselves defined and discussed in OAIS. The point about the designated community is that unless you have something like that, preservation is not testable. Just to say we're preserving something is to a large extent untestable, as we'll discuss in the course, and there are other courses to do with audit and certification that one might be interested in. Designated community is the group of people, people with a certain knowledge, or communities with a certain knowledge, for whom a repository guarantees will be able to understand and use the data, because its understandability, and in particular independently understandable, is the key criteria. And of course authenticity is extremely important, because if one preserves something but one doesn't know for sure that it is what you think it is, then all the efforts may have gone to waste. One key concept that that's worth pointing out is representation information, which is essentially a whole set of special metadata which is related to understandability. And one can, in terms of some of the tools and techniques that are discussed, and there are more detailed courses available covering them, facilitate the understandability of the designated community. And in fact OAIS introduces many other concepts that in broad terms could be described as metadata. The problem with using that term is that it's not really possible to ask, have I got enough, have I got the right sort, and so forth. So the course will give a solid basis for those considerations. Threats to digital objects, I've covered understandability, but very widely recognized across the world, across disciplines, data managers, data practitioners, researchers. These are some of the top threats that are recognized. So understandability, semantics, format, essential hardware and software, authenticity in terms of the chain of evidence as digital objects are handed on one to the next as individual people retire. An interesting one is the digital rights management, which may prevent preservation activities that need to be addressed very carefully. Of course, there is the being able to find, given an identifier, find the data if one is looking after the data, then one's own organization may cease to exist, or if one gives it to a repository, they may fail. Even if they continue to exist, they may not maintain the understandability to the designated community. So all of these are very important threats, and we'll cover these and some of the ways in which these can be tackled. One last very important consideration is who pays and why. Digital preservation requires resources, as you should have seen. There is no magic solution, magic format, magic material, media that we can rely on forever. It requires continual effort by somebody. It requires resources. For how long and why? So we illustrate the answers to this in terms of the value, either actual immediate value or potential value, and how that is used to judge whether and for how long something should be preserved. So all of these things will be covered in the training course. This is particularly the overview of digital preservation, but there are a number of more detailed courses. For more information, please look at this web page, and in particular the training events page, which gives the details and the contacts to arrange these training courses, one-day courses or two-day courses with clinics, much more detailed, in-depth, looking at examples, trying to solve your problems, and summer schools. So, thank you for listening. I hope we'll see you at some point in these courses.